Alright guys, now we're going to look, now that we know what polynomials are and how to work with them, we're actually going to look at how to graph them. And we're going to look at a few different things, little clues that help us figure out what this graph is going to look like. So the first thing we're going to try to figure out about a polynomial is its end behavior. Now there are basically 4 different options for end behavior. And we get these from looking at the actual polynomial itself. Now a couple things we could have a leading coefficient that is positive, or we could have a leading coefficient that is negative. And if you guys remember, the leading coefficient is the coefficient in front of the highest degree. So if I had a polynomial like negative 3x squared plus 2x, that would be a negative leading coefficient because my highest degree polynomial, the highest degree has a negative in front of it. Now what else can happen is if I look at the degree of my polynomial, I could have an odd degree or I could have an even degree. So this affects the number of that exponent. So it's not whether or not the leading coefficient is positive or negative, it's if that exponent itself is an odd or an even number. So that would be like if I had 3x to the 7th minus 2x squared plus 3x. That would be an odd degree because highest degree is 7 and that's an odd number. Okay, so what this is going to do is it's going to create a few different end behaviors based on which of these things my graph has. So the first thing that's possible is I could have a positive leading coefficient and an odd degree. Now a really good example of that would be a function such as y equals x. Y equals x is an odd degree, the degree is 1, and it's positive because my leading coefficient is just a positive 1. So if you think about the end behavior of y equals x, my ends are going that way. So my graph is going to have ends that do the same thing. Now what that means, it doesn't matter what my graph does in between. Okay, my graph could look like that, doing all sorts of crazy stuff in the middle. That doesn't matter. What matters is that my ends of this graph, one is going down and to the left, and one is going up and to the right. So that's the end behavior I have here. So if it's a positive leading coefficient in an odd degree, my end behavior is going to look like this, like y equals x. Alright, another option is it's still an odd degree, but it's a negative leading coefficient. So that's going to be something similar to y equals negative x. And you guys know what y equals negative x looks like. Very similar, but going in the opposite direction. So what that means is my graph, it doesn't matter what it does in the middle, I know my ends, one's going to be up to the left and one's going to be down to the right. And this graph can do anything in the middle, it doesn't really matter what. But it's my end behavior that I look like. So a negative leading coefficient in an odd degree has an end behavior that looks like that. Alright, now other options are if my leading coefficient is even. So if it's even, a good example of that one that you guys already know is y equals x squared. So y equals x squared, you guys know, is a parabola, which means both ends are going up. So it can be the same idea for my end behavior here. It doesn't matter what my graph does in the middle, the ends are both going to be going up. So that's a positive coefficient and positive leading coefficient and an even degree. So then that leaves my last option here, which is a negative leading coefficient and an even degree, and that's like y equals a negative x squared. And you guys know that's also a parabola, but that negative flips it and it's going down. So that kind of end behavior, again, it doesn't matter what my graph does in the middle, if it's a negative leading coefficient and an even degree, I'm going to have both ends facing down. And then my graph's going to do whatever it wants in the middle. Again, we're looking at the end behavior here. So if you guys look at those green arrows, let me move that over, are going to tell you what the end behavior is going to look like in each of those boxes. So that's the first thing we can do to help us graph a polynomial is we look at the leading coefficient and the degree to determine its end behavior. Now you also can describe this end behavior like what we did previously, and we're not going to spend a lot of time on this because we'll do more in class. But what I mean by that is if we had something like, if I look at this graph with an end behavior like the top left, as x approaches infinity, if my end behavior looks like this, as my x's approach infinity, that means my y's are approaching infinity. And in a graph with that same type of end behavior, as my x's approach negative infinity, on this kind of end behavior, my y's also approach negative infinity. Alright, so after we find our end behavior, the next thing we're going to do to help us graph a polynomial is to find the y-intercept. Now if you guys remember, the y-intercept is where my graph crosses the y-axis. And if you think about that, any graph, okay, if it crosses the y-axis, all that means is that the x value is 0. So the easiest way to find this is just to plug in 0 for x. And again, it tells you that it's easier to find this when it's not factored. You can still find it when it is, but if you don't have a calculator, it's really simple if it's not factored. Because if I look at this term right here, I'm going to take every x and fill in a 0. And if I multiply something by 0, I know it goes away. So my y-intercept here is just negative 7. So I know this graph is going to cross the point 0 and negative 7. Now the next part I need to find is my x-intercepts. Okay, and this one we're going to need to use the factored form for. Now x-intercepts, if you guys remember back from Algebra 1 and Algebra 2, those actually have a couple different names. X-intercepts are also called the roots, or the solutions, and they are also called the zeros. And you're going to see zeros come up a lot more often. So the x-intercepts we need to find, we take each factor and we set each factor equal to 0. So to do this one, it's already factored, so I'm going to set each factor equal to 0. So my first one is x. If I set x equal to 0, x is 0. If I take this next factor, it doesn't matter that it's to the third power. We're not going to worry about that right now. We'll look at that later. We just want to find the actual 0. What makes x minus 3 equal to 0? And that value is 3. What makes x minus 2 equal 0 is 2. And then what makes x plus 7 equal 0 is negative 7. So this graph has 4 x-intercepts, or 4 zeros, and they are 0, 3, 2, and negative 7. So that graph is going to cross the x-axis in 4 places. So the last thing we're going to do these graphs is after we found the zeros, we're going to see what our graph does at that point. So we're going to find the behavior at the x-intercept, and this is a lot of times called our multiplicity. So the multiplicity is actually where it's going to matter what power that factor was raised to. So now we're going to look at that. So there were 3 different kinds of multiplicities. If that multiplicity is exactly equal to 1, that just means I have a factor and that factor is exactly equal to 1. So that's like x plus 2 to the first power, or just x, or x minus 3. Those are all raised to the first power. So that multiplicity, that means my graph is just going to cross right there. So what that looks like is there's 2 different things. So if I have, that's my 0. Let's say I have a 0 at 1. If my graph crosses, it's just going to go straight through that point. From either direction, it's just going to go right through it. If my multiplicity is even, so that means if that factor is raised to an even power, like x minus 2 to the 4th power, or x plus 1 to the 8th power, or x squared. All of those factors are raised to an even number. That means at that 0, my graph is just going to touch at that location. So if I have a factor to an even power, such as, let's say I have, this is a 0 again, it's just going to touch at that point. So my graph would look like this, just at that specific 0. And then the last option is if I have an odd multiplicity, but it's bigger than 1. So that's, 3, 5, 7. If I have x to the 3rd power, or x minus 2 to the 7th power, it's going to wiggle at that point. So it's going to look really similar to where it crosses, except it's going to kind of curve at that point. Okay, so it's really similar to if you think about y equals x cubed, what that parent function looks like. It curves as they get closer to 0. So that's a good example of that wiggling. So what we're going to do here now is we're going to look at that same previous question, and we're going to try to come up with what this graph is going to look like. Okay, and we're just going to look at the first couple things that we talked about. So let's start with our zeros and our multiplicity. So I did on the previous question my zeros. This graph is going to cross the x-axis at 0, 3, 2, and -7, because those are the numbers that make this equation equal 0. My other thing now I'm going to find is the multiplicity. So the multiplicity of that factor is 1, which means that graph is going to cross. The multiplicity of 3 is 3, which means that graph is going to wiggle. The multiplicity of 2 is 4, that's an even number, so that one's going to touch. And the multiplicity of -7 is 1, which means it's going to cross. So now I know what that graph is going to look like at those points. So we're going to see what that looks like real quick here. So I'm going to mark those zeros. I've got -7, 0, 2, and 3. And this isn't going to be perfect. It's going to be kind of a real quick example of how this is going to look. And let me erase that so I have more space. So I know end behavior of this graph. This graph is positive because there's no negatives in the front, so this is a positive leading coefficient. And now I also need to find the degree of this graph. Now, if it's already factored, in order to find the degree, I had to add up all these exponent powers. So I've got 1, 3, 4, and 1. So if I were to multiply all of this out together, it would go to the 9th power. So this is a 9th degree, which means this is odd. So this is odd and a positive leading coefficient. So an odd positive leading coefficient looks like y equals x. So that's what my ends are going to look like. So all I'm going to do now is follow this graph through those points, just like what it tells me to do. So as I get to -7, my graph is just going to cross. So I'm going to go towards -7 and cross through that point. Then I'm going to come close to 0. And when I go to 0, again, I'm going to just cross. Then I'm going to go back towards 2, and at 2, my graph is just going to touch and then bounce back. So I'm going to go to 2 and then bounce back. And then finally at 3, my graph is going to wiggle. So it's going to go up towards 3, but instead of just crossing, it's going to curve a little bit. And that's just kind of a rough sketch of what that graph is going to look like. Now, without a calculator, we don't need to worry about how high or low some of these points are. So we don't need to worry about the heights here or the height there or there. We don't need to worry about those. We just need to worry about what this graph does at the x-axis. So to see this a little bit better, we're going to look at one last thing. This is similar to your homework. I've got a little chart here that kind of helps us see this and figure this out. Let me move this out of the way. So let's look at this first one up here. It gives me an already factored function, and it tells me to find these three things. I want to find the highest powered term. Now again, if this equation is already factored, I'm going to have to add this up and see. So I have a term of 2 there, 1 there, and 1 there. So if I were to multiply this whole thing out, it would be 2 plus 1 plus 1. The highest power would be 4. The zeros of this graph, I look at each factor and what makes each factor equal 0. Now 2 is not a factor. Okay, it changes the stretch of my graph, but it's not actually a factor. It doesn't change my x-intercepts. The only factors I'm going to have are -1, 3, and -5. So I'm going to write those over here. And then, just for practice, I'm going to find the multiplicity. So the multiplicity of these graphs, at -1, this graph has an even power, so it's going to touch. At 3, it's 1, so it's going to cross, and at -5, it's going to cross. If I wanted to find the y-intercept, I could plug in 0 for x, and that would be 2 times 1 squared times -3 times 5. So now you see what I'm saying, where it's a little easier if it's already, if it's not factored yet, but if it is factored, you can still find it. That y-intercept would be at 0, -30. So that's just another clue to help you with your graph. Okay, so now I'm actually going to draw this graph here. So the last thing I need to know is my end behavior. So my end behavior, this is a positive leading coefficient. And again, if my highest power term is 4, so that means it's an even graph. So it's positive and it's even, which means my ends are going to be up. So now I'm going to mark my zeros. I've got zeros at -5 and -1 and at 3. And those are not marked very evenly, but let me try and write that in there. There we go. And now I'm going to go ahead and draw this graph. Okay, so my arrow is first, my graph is first going to go towards -5, and it's going to cross through -5. And I missed. So I'm going to cross through -5. Then at -1, it's just going to touch it and go back. I'm going to go through 0, -30, and then I'm going to cross at 3. And there's my graph. All right, now if you look at the bottom again, there's one last example if you want to see another, and that's again similar to what your worksheet's going to look like. Just remember, okay, let's go ahead and do that one together too. We'll do the graph last. We're going to answer those questions first. So this is asking me, first of all, to find the root and the what it does actually at that place. So it already gives me my zeros. My zeros are -2, 1, and 3. So at -2, this graph has a multiplicity of 1, which means it's going to cross. Okay, at the next one, at 1, it has a multiplicity of 2, so it's going to touch. And then at the next one, at 3, it has a multiplicity of 3, which means it's going to wiggle. The end behavior is based on if it's positive or negative, and it's positive. And if I add up those, if I add up my powers there, I've got 1, 2, and 1, so that's an even number, so it's going to be positive and even, which means it's going to be up and up. It's going to look like y equals x squared. And then my highest degree term, again, we just said that would be x to the 4th if I multiply that all out. So if I were to draw this graph, I'm going to mark my zeros, which are -2, 1, and 3. And then I've got my end behavior. It's going up and up. At -2, my graph is going to cross. At 1, my graph is going to touch and go back. And then at 3, it's going to wiggle and then finally go up. And that's it. And just remember, guys, these are kind of just a rough sketch. Just make sure you understand what these graphs are doing at the x-axis and that you're finding your zeros. And then you'll be good.